Hey y'all. Today's objective is function notation. So you've been introduced to functions, relations and functions, and you know about domain and range. So we're going to go into a little bit deeper about functions. Function, a relation that assigns one output, which is your y value, to exactly one input. So when you hear output y value, that's also going to be your dependent, and your independent is going to be your input. Function rule, an equation that describes a function. So we've also practiced writing equations when you've given an input and output, and we've practiced in a calculator and writing input-output equations. Function notation, so here's the new part. Use this, f parentheses x, which we read it f of x. Use f of x to indicate the output values. So an example, you would see an equation y equals x plus 3. Function notation would replace the y with f of x. F of x equals x plus 3. It's the same thing. What this is saying is this is a function of x. A function with the variable x as your input. And this replaces the y. So we're going to practice. So example, evaluate the function. So here, example A, we have a function. F of x equals negative 3x minus 10. Don't worry about that right now. This is a function in terms of x. And then for x equals 6, so copy this down. F of x equals negative 3x minus 10 for x is 6. So I've rewritten the function. And instead of x, I'm going to do f of 6 because my x value is equal to 6. So f of 6. What that means is we have to substitute a 6 in wherever you see an x. And I put a note here. You want to use parentheses. Whenever you're substituting in values, you want to always use parentheses. So negative 3 times 6 minus 10. Negative 3 times 6 is negative 18. Negative 18 minus 10 is negative 28. So that means f of 6 is equal to negative 28. In other words, this is your x value, and this is your output, because that's what it equals. This whole thing, f of x, so that was your y value. So your input was 6, and your output was negative 28. We put in a 6 for x, and we got out a negative 28. Your answer is an ordered pair, because eventually we're going to get to graphing linear equations. So your answer, you can see it both ways. This, or you might even see y equals negative 28. It all means the same thing. Let's do another one. This time, instead of f of x, I just have y. Y equals negative 2x squared plus 7. X equals negative 4. So I've substituted in negative 4, and again, you want to use parentheses. And I have y equals instead of f of x, but they mean the same thing. Negative 2, so we have to do negative 4 times negative 4 is going to give me a positive 16 plus 7. Negative 2 times 16 is negative 32 plus 7. And this equals negative 25. My ordered pair is the x value, negative 4, and then my y value, negative 25. Also, you could have f of x equals negative 25. Alright, example C says g of x. Same thing, it's just a different function notation. G of x is equal to negative x plus 2. Now, negative x means the opposite of x when x is negative 3. I've rewritten my function, and I know that I'm going to substitute negative 3 in for x. So I use parentheses, and I put in negative 3. So the opposite of negative 3. The opposite of negative 3 plus 2. The opposite of negative 3 is going to be positive 3. In other words, this is like a negative 1. Negative 1 times negative 3 is going to be positive 3. The opposite of negative 3. 3 plus 2 is 5. So g of negative 3 is equal to 5. So that's like saying y is equal to 5, and then I have my ordered pair, negative 3, 5. But this negative in front of the variable can sometimes be tricky. So this one, h of x. You try h of x. Here's the function, negative 2x minus 4 when x is 5. So I want you to copy that down, pause the video, copy this down, and work it out. Press play when you're ready to see the answer. Alright, so h of 5 is equal to negative 2, 5 minus 4. Make sure you use parentheses. And then I'm going to get negative 10 minus 4, and that's negative 14. So h of 5 equals negative 14, or you could write it as an ordered pair. So h of 5 is negative 14, or y equals negative 14. All right, so some more examples. Find the range of the function for the domain is negative 2, 0, and 5. So we've gone over range and domain. So the range is the y values or the output. The domain are the x values or the input. The domain are the independent values. The range are the dependent values. But that's to come. So in our function, we need to input our 3 domains to get the range. So in A, we're going to have first f of negative 2 equals negative 2 minus 6. Negative 2 minus 6 would be negative 8. So that was the first one. We have to do this one again with 0. So f of 0. 0 minus 6 is going to give us a negative 6. And then we need to do it a third time with f of 5. F of 5 means 5 minus 6. And 5 minus 6 is negative 1. So to find the range, the y, the output, I have put in my domain, my input, to the function. And so my range is the set negative 8, negative 6, negative 1. So you can write it like that. The range set is negative 8, negative 6, and negative 1. Let's do B. Instead of y, I don't have f of n, I have y, but I'm still going to put my values in. So negative 4 times negative 2, and that's going to give me y equals 8. I'm going to do it with 0. Negative 4 times 0, and that's going to give me y equals 0. I'm going to do it one more time with negative 4 and 5, and that's going to tell me y equals negative 20. So my range set, my set of range values are going to be 8, 0, and negative 20. Alright, so this last one has the x squared value, so be careful. When you input it, g of negative 2 means negative 2 squared plus 1. Negative 2 squared means negative 2 times negative 2, which is going to give us a positive 4. So 4 plus 1 is 5. When I substitute in g of 0, 0 squared plus 1. Well, 0 squared is 0 plus 1 is going to give me 1. And then the last domain value, g of 5, is going to be 5 squared plus 1. 5 squared is going to be 25, plus 1 is 26. So my range set of numbers, my range is going to be 5, 1, and 26.